All right, we are continuing with Chapter 2 today. This is day 3 of Chapter 2. We are solving compound inequalities. This is in your notes, correct? Yes, so it says a sentence formed by joining two sentences with the word and is called a conjunction. For a conjunction to be true, both statements are true. So, for example, if you say, tomorrow I'm wearing jeans and a sweatshirt, you're wearing both, right? You're wearing jeans and a sweatshirt. What if you say, tomorrow I'm wearing jeans or a sweatshirt?
It could be either or.
It could be either one, okay? So, and it has to be both, or it could be either one. So, a sentence formed by joining two sentences with the word or is called a disjunction. For a disjunction to be true, at least one of the sentences has to be true. That's more of like an English lesson. Make sense?
Yeah. English and math.
English and math. I know. The two core subjects coming together.
And bad way.
All right, next. We're going to look at these. So these say solve and graph. Solve is what we did yesterday where you get the x part by itself. 1 and 2 are already solved. Do you see that? So we're just going to graph them. So we want to graph the x values that are greater than -3 and less than 4. What part of that graph is greater than -3 but also less than 4? Yeah, things like -2, -1, 0, 1, 2, 3. That's it. So that's the area that's in between those. Okay? So hold on. I'm going to draw it a little bit neater than that. Hold on. I thought that it erased part of the arrows. So what you need to do is start at the -3. End at the at the +4. So it'll look like that.
Alright, I'll do it next time.
I know, sorry. I thought the arrows were going to drop off, but they did not. So the way this would look if we wrote it as one big inequality, because the ands you can write as a big inequality, -3 is smaller than my x's, which is smaller than my 4's. That's how you would write this as a compound inequality. Okay? So it just goes in order on these. Start with the smaller number. Then the x, the solutions are in the middle, and then the bigger number. Now, the cool part is, I think it's cool, the ands can be written like this. So you're really putting two inequalities in one. The not cool part is that the ors cannot be written like that. Or is just what it is. Okay? So for my ors, I now want the x's that are greater than -3 or smaller than 4. So basically, you tell me. If it's greater than -3, where would that be on the number line?
-2.
To the right. Now, does it have to make both of them true or just one of them true? Just one, because it's an or. So this graph actually still goes all the way down there too. And where are numbers less than 4?
Like that, the other way?
To the left. So this is actually going to be the whole number line.
That's weird.
I know. So you would just shade in the number line. And the solution here is actually going to be every number, right? So all real numbers. Technically the open circles are there, but then you color it in by the next graph, so no, not really. Because, like, for example, -3 is a solution for this one. Positive 4 is a solution for this one, so they don't stay open. Tricky. So here I want and. So does it have to make them both true or just one of them true? Both. So I want to find the spots on my number line that are greater than -2 and also greater than 3.
So basically everything in between.
So you're telling me if you think it's in between again, like 0's a good tester. Does 0 make both of these true?
Oh wait, no.
No. So it can't be in between. What's a number that makes both of these true? Yeah, like 4 would make them both true, right? So don't write this. I just want to show you. This graph would be going this way, right? Mm-hmm. This graph would also be going this way. So what part of our number line makes both of those inequalities true?
Everything beyond 3.
Everything to the right of the 3. So that's the only part I can put on this graph. So my actual solution is just that second half. To make both of them true, it has to be greater than 3. This is confusing. That's why we're practicing nice and slow. All right. Now, number 4, same thing, but now we have an or. So I need my -2, I need my 3. For or, does it have to make them both true or just one? Just one. So now would 0 work? Yeah. Okay. Because that's making this one true. Now, anything to the right of 3 is still making both of them true. So that's good. It can make both of them true in an or, but it has to make at least one of them true. So here we start at -2 and we go to the right. So now it would be y greater than -2. All right, number 5. I want the x's that are less than -2 and greater than or equal to 5. So very lightly, because we'll probably end up erasing some of this, the part that makes the parts that are less than -2 would be down here, right? The parts that are greater than or equal to 5 are over here, right? This is an and. So what part of the number line works for both? So you're telling me that 0, for example, makes both of those true? No, it doesn't make either of them true. To the left, how many things are true? Are they both true? No. Like -3, for example, is obviously wrong here. What about like 6, 7, 8? Would that make this one true? No. So there is actually no part of the graph that makes them both true. So this is a no solution. Now, the or part is actually what I just erased, right? Because if it makes this part true, that works. If it makes this part true, it also works. So that is my answer. The question is my answer.
Wait, what?
We're kind of taking what they wrote and simplifying it a little bit. Like we took this, it's sort of like a riddle, and we decided, hey, nothing's going to work. In the previous example, we looked at it and was like, well, one of them doesn't matter, just make sure this one's true and then it works. Here, I'm saying, well, yeah, this one and this one both work, so they both need to be included in my actual answer. These are tricky. I will give you that. They are tricky.
That's a light word.
These are heavily tricky.
Heavily tricky. All right, questions.
Dyslexic.
That's good.
Hopefully.
So in the first example, do you remember how I wrote the and problem as one big inequality? It was like -3 is less than x is less than 5 or something like that. This is what this is. This is an and problem written with two inequality symbols, variable in the middle. You want your answer to have two inequality symbols and a variable in the middle. It's basically like solving two inequalities. Here's one. Here's the other one. Do you see that? Like cover up the -21. That's a question we could have done yesterday, right? I'll color over it. Like if I get rid of this, you could have done that yesterday, right? Okay, if I cover up this, you could have done that one yesterday. Am I right? Okay, so we're basically doing two problems from yesterday at the same time, okay? It's like solving an equation that has two equal signs. So what I want you to do is draw a line down from each of your inequality symbols. Okay? Now, whatever you do to the middle, you're going to do to both sides. So I want to get rid of the -5, so I'm going to add 5. But it's like I'm solving in 3 sections at once. So I need to add 5 here. I need to add 5 here. The signs stay the same. The only time they'd switch is if you multiply or divide by a negative. So -21 plus 5 is -16. That is less than or equal to 4n is all I have left in the middle. Is less than, what's -1 plus 5? 4. I am going to pause here and you're all going to silently look at the board and see if you can make sense of what just happened. Does it make sense?
Yes.
Okay, we figured out what we needed to do to get the variable alone in the middle, and then you did that to each of the 3 sections. All right? Now, how do I get the n by itself? Now I divide everything by 4. Those are gone. -16 divided by 4 is what? -4. I don't flip anything though because I divided by a +4. In the middle I have the n. And the back, what's 4 divided by 4? 1. So that's sort of the first half of the problem. Are you all okay with this? Now, these only work if it's the smaller number. A less than or a less than or equal to are both fine. The variable, a less than or a less than or equal to, and then the bigger of the numbers. Is it in that form right now?
Yeah.
Yeah. So on my number line, I need the -4. And I need the 1. Do you see how n is bigger than -4? But the n is smaller than 1. It includes the -4, so that one needs to be filled in. It does not include the 1, so that one's open. And is it the space outside those numbers or inside those numbers or to the right or to the left? What do you think?
It's less.
It's in the inside, right? Because it has to be smaller than the 1, but it also has to be bigger than the -4. And if you want to check, pick a number in there. 0 would work, okay? If you plug 0 in, you would end up with -21 is less than -5. That's true. And -5 is less than -1. That's also true. So that range works. What are your questions? Okay, now number 8. is an or problem. Or problems is basically two problems from yesterday written separately. They stay separate and they have the word or in the middle. Okay? So we can do them completely separately. When we get to the bottom, I'm going to write my answer with the word or. How do I do the first one? You add 3 to both sides. So 2x is less than or equal to -3. Then what?
Wait, would it be -2? Oh, it's +3. Never mind, I was 2.
Yes? Divide by 2. Good. So 2 is less than or equal to -3 over 2.
Oh, no.
2 is what? You mean x? No, she said 2 is equal.
Whatever, you know what I meant.
I usually did. I was confused. Why send me else up?
All right. Now, we've finished the first equation. Okay, let's just start on the second. What do I do to start? Add 12. Add 12. So 3x is greater than 12. Divide by 3. Divide by 3. X is greater than 4. That's my answer. Now, when we graph these, it might change what we're saying a little bit. Like we might be able to just focus in on one of them. Sort of like on the example from your notes where the one section of the graph was included in the other, so you could kind of write it or not write it. But this one I think is going to work out just fine because we have the 4 here. We have the -3/2 over here. The -3/2 is included, so I'm going to fill that in. And I want the solutions that are less than that. So I'm going to go to the left. Is the 4 included?
No.
No, so I'm going to leave that part open. And I want the numbers that are greater than 4, so that's to the right. And since it's an or, both pieces of the graph are fine. It can be in one section or the other section, and we're good. So this is an and, but it's not written all together. So I can solve them separately and then maybe combine them at the end if it works out well. Okay? So how would I solve the first half? Subtract x. Good. So 3x minus 3 is greater than -9 plus 3. So 3x is greater than -6. Then divide by 3. And x is greater than -2. That's when the word and comes in. Okay? Now we got to do the other one. Doesn't really matter. All right, let's do the 5. So I'm going to add 5x to both sides. So I have 6 is greater than 1 plus 2x, right? Then what? -1 minus 1. 5 is greater than 2x. Then I will divide. 5 over 2 is greater than x. Yep, we usually write it with the x in the front. So I am a little out of space, but I'm going to have x. X is the smaller part. So switch your sign. So right now, I'm going to circle it all together. I have this and the word and that. That is not really the answer because we can write it in a neater way. let's start with the smaller number. Ands we usually write as one inequality. Smaller, variable, bigger. So what's the smaller of those numbers?
-2.
5 halves is littler than -2. So I have -2. Now, x is bigger, so now I would write it like this. Then I can put the other inequality on the end. That is the correct answer. Remember, those symbols on and problems are always less thans or less than or equal to's. So smaller, one of the less than symbols, the variable, another less than symbol, the larger. We do it like that because that's the way it appears on the graph when you have an and problem. It starts at the -2, it stops at the 2/5, 5 halves. You know I'm dyslexic. It's the part in the middle. Yeah, I mix up numbers all the time. I said 2/5, but I meant 5 halves. All right. Any questions? So let me just reiterate. Correct answer, but not final answer. Final answer, graph. Number 10, we're looking at another or. So we can solve them separately, write the answers separately, put the word or in there. They're a little easier, I think, than the ands. All right, in the first half of number 10, what do? Add the x. Add the x. So 5x plus 3 is greater than 13. Okay, waiting. -3, thank you. So 5x is greater than 10. Divide by 5. X is greater than 2. Or, now I need the other half. Or
you could do 16 minus, -8 minus 16.
Okay, you're going to subtract 16 from both sides. -3x is greater than or equal to...
Okay, you don't have to keep saying 2.
Okay. Is anyone's head going, woo, woo?
Yeah, we gotta flip it.
Yeah, we are about to flip because we are dividing by a negative. All right. Chill out. So I want to graph this on a number line, and then I'm going to sort of just rethink if I'm right. So to put this on a number line, the smaller of the numbers is which one? The 2. And am I going left or right from the 2? Right. Okay. Then I want the 8. It includes the 8, and then left or right? Left. And this is an or. So we can go past the 8 because that's still making the other inequality true. We can go past the 2 because that's still making the x is less than or equal to 8 inequality true. So what's my actual answer here? All real numbers. Every number satisfies one of those inequalities. So, first of all, I don't see the word and or the word or, but which one is it?
And.
This is an and. If you want to write yourself a little note, it has to make both of them true. This is an and, okay? Shh, quiet down, please. So this is one of those where I have 3 sections I'm working with. Focus on the middle to decide what to do first. What do I need to do? Subtract 7 from both sides. All right. What is 10 minus 7? 3 is less than. Negative 3x is less than or equal to 5. Here's where it gets tricky. What am I going to do? Divide by negative 3. In all parts, I'm dividing by negative 3. Woo, woo, correct. Now I have negative 1 is greater than, x is greater than or equal to negative 5/3. Now, is negative 5/3 smaller than negative 1 or bigger than negative 1?
Bigger? Bigger. No, smaller. But it's negative.
It's negative, so it is less than on the number line, right? So it has a smaller value.
Yes, negative 5 there.
Right. So I need to rewrite this because now this one is the least. This is in the middle. This is the greater of them. Okay? So when I write my final answer, it needs to be negative 5/3 less than or equal to x less than negative 1. And on the number line, the negative 5/3 is to the left. Then the negative 1. Negative 1 is not included. Negative 5/3 is included. I want to be greater than this one, but I want to be less than this one. All right. Number 12. Are you ready? So we want to find the value of x that would make this part smaller than this part and this part smaller than this part, okay? So you can separate them if you want. That might make it a little easier since we have so many variables going on. So I'm going to rewrite this guy and this guy because I honestly am not really sure how to keep all the variables straight since there are x's in so many spots, okay? So I think this is going to be the easiest way to go on this one. And then I can rewrite it back as a compound inequality without the word and at the end. Any questions? Okay? So let's focus on this guy. How would I get the x by itself?
Minus 2x.
I am going to subtract 2x from both sides. So negative 3 is less than x plus 1. Okay, then what? Minus 1 minus 1. So negative 4 is less than x. I'm actually going to leave it like that because that might end up being in the front of my final answer, you know, so we don't have to like flip it and flip it again. Just pause for now, like put a pin on it, and that might actually be the form we want. Now over here, what do I do?
Minus 2x.
Subtract 2x again. So I have x plus 1 is less than 2 minus 1 minus 1. So x is less than 1. And I have the word and in the middle. So do you see what I'm saying? This is the smaller one. So we're going to sort of write it in this backwards form for my final answer. Since it's an and, I'm going to put it all together. So -4 less than x less than 1. And on the number line, I would have the -4 and the 1. And I want the space in the middle so that it's bigger than the -4 but smaller than the -1. Less than the -1. Now, if you don't want to separate it, if you're like, I don't need to separate it, I'm fine. See how these both have 2x? You could start by subtracting 2x from everything. That would get all your x's in the middle. And then you could solve like we did on the previous and problems that were written this way. I just think when you have x's in all 3 sections, it's easier just to kind of split everybody up. It's like when your kids are being bad at home, you know. There's just too much going on. Split everybody up, put them in separate rooms, and take care of them. Same thing here. You got to take care of this, and then when everyone's calmed down, you can put them back together. That was a great analogy. Let me just say. Way to go. Okay, what did we learn about today? It was a rough one. Anyone remember what it's called?
No.
Yes, you could even put like today we struggled through compound inequalities. Remember, we're reviewing tomorrow. So this is a good way, I think, to end the notes for the week. We get a whole day of questions tomorrow.
Today we struggled through compound inequality.
All right. And then remember, though, the quiz will have these on them. It'll also have the easier ones on them, too. The stuff we did Monday where we were just graphing probably feels like a piece of cake now. Okay? And then we'll have the regular ones from yesterday and the compounds as well. All right, here comes homework.